Hi everyone, I'm Luke Marsden from Helix ML, and I'm here with my friend Jez.
Hi there, I'm Jez. I'm a computer programmer at Kaizen, and I'm here to learn about spec-driven development and Helix.
Nice. Cool, yeah, so let's just chat. And we've got beers, so we're keeping it pretty informal. And our friend Rob might join us in a bit, but he's been delayed. But when he does come, I'm going to make him install our software on his Mac. He's going to be one of our very first users. But yeah, let's talk about spec-driven development. Shall I start just with an overview, or do you have questions you want to dive in, or?
Well, I guess I could say why I'm here today is I reached out to Luke because I've been, probably like all programmers these days, doing more and more prompt-driven development using applications like Cursor to, try and, in theory, improve our speed of the development. And I was sort of asking a question, which was, I kind of feel like I'm working faster probably than I was before with prompting, and definitely, just some of the autocomplete features. But it was like, I feel like I should be going faster. But at some point, I don't necessarily want to go straight into vibe coding. I still want to look at the code myself. And it's like, right, what are you doing, Luke?
Yeah. And then I rambled at you for an hour at a party, and now we're here. So that's good. So yeah, and I think, just to sort of set the scene, I think it is a really interesting time to be alive, because AI coding is dramatically changing our industry. And I think people outside the software industry don't really see what's happening yet, but I think it's going to affect many industries in the same way. And the way that it's affecting software engineering is that there was a Stanford study that came out recently that talked about how they surveyed lots of teams who are using AI like coding agents, and they looked at like the impact on the team's velocity, and those teams ranged from getting made 2.5 times slower all the way up to 10 times faster, depending on how well they adopted the tools and how they updated their processes, and also what tools they built around these agents to help manage them. And I can speak kind of, well, I guess there's kind of two pieces maybe to talk about. There's kind of the need for spec coding, and that's why we're here today, really, is sort of spec-driven development. And then there's the need for sandboxes. So the idea with spec coding is actually really simple. There's actually a few different definitions of spec coding that the industry's working on, kind of figuring out what everyone agrees on. But the one that I really like is just to think of spec coding as, it's really simple. You just get the coding assistant, you get the agent, before it does anything, you get it to write a plan about what it's going to do. And it turns out that if you get it to make a plan before it does it, and you as the human review the plan, and you find maybe across 3 pages of the plan, like these 2 things that it got wrong, and you correct it before you hit go, then it will make far fewer mistakes, and you will not have agents going off the rails. Because that's one of the things that can make you kind of err on the sort of 2.5 times slower side, is if your agents are just randomly doing stuff. If they're given poor prompts, or they don't actually explore the code base properly. A pain point we get a lot is like, agents love writing code. Like, they're really good at writing new code. They write so much new code that you end up with 3 copies of the same thing if you're not careful, because they haven't noticed that there's something in the code base that already does that. So actually, when we were building Helix, we ended up with 3 different implementations of windowing systems in the browser for like dragging windows around. because the latest version of the UI doesn't have that, but for a while we had like windows that you could drag around with different things in. Every time I said, like, make this component have a windowing system, it would invent another one. And I hadn't noticed, because I was too busy vibe coding, like you said, that it had done 3 different implementations, and each implementation had its own set of bugs. Like you resize the windows and it would like resize them in the wrong direction and all this shit. So vibe coding is a really good way of a human who has a view over the whole code base, helping the agents avoid making mistakes, or helping the agent to actually understand the architecture of what it's working on and avoid duplication. And I guess the other part is around, like, why do you need sandboxes? Well, what is a sandbox? It's a way of basically putting the agent inside a box and saying, like, you'll only do, basically it's a security mechanism to say, like, you can't escape from the environment you're in and do random stuff. Because the alternative to that is that everyone runs an agent on their own computer, directly on the computer. And that's kind of where most people are right now, is that they use Cursor and they run the agent locally, or they use Claude Code and they run it in their terminal on their machine. And yeah, so I've talked about my painful experience of like not having specs. My painful experience of not having sandboxes is, so a couple of weeks ago, I had some big customer demos in Paris that I had to get ready for on the Thursday. So early on Monday morning, I was working on, I had 5 agents running in parallel on my machine. This was before we started using Helix to develop Helix, which we do now. But I had 5 agents running on my machine. One of them looks at all the uncommitted changes in the repo and says, these changes have nothing to do with what I'm working on. I'm going to stash them all. And this, unfortunately, was after I'd done a few hours work with all of these agents, and none of them had done a commit, which, to be fair, was a mistake. And I tell the agents all the time to commit and push. But but so step 1 was this agent stashed all of these other agents' work. I was like, okay, fine. Got into a bit of a mess. Managed to kind of start pulling the features out of the stash one at a time, but didn't manage to pull all of the features out of the stash. When the following morning, disaster struck, because I was asking an agent to set up what's called an orphan branch on the Git repo, because that's one of the features we use. And guess what it decided to do?
I guess just attach it or something like that, just so that it wasn't relevant.
Worse than that, it did rm minus rf dot.
Oh.
On my entire Git repo.
Okay.
And guess what hadn't been pushed? The stash.
Yeah.
Like, you don't push stashes,
the stash
they're
is
local.
Yeah.
So then I had to work extra hard for the rest of the week to redo all of this work. And I did make it to the demos, but it was hairy. And so that's an example of how you can get slowed down. But the solution to that is to have each work item that you're doing happen in a fully isolated environment. And luckily, containers are really useful for this. But people don't normally develop inside containers. It is possible, and VS Code's got dev containers and stuff. But yeah, so my view is that it's super useful to give each agent like its own isolated environment and a specific branch for the job that it's doing. So yeah.
And you've added sort of, I guess you're using containers. It's just that you're also putting the desktop in there.
Yes.
So
yeah.
Just actually see what's going on as well at the same time.
Mm-hmm. Yeah. Do you have other questions? I'm going to go into
I'm sure.
Spec coding.
I'm definitely coming from a spec driven development side rather than necessarily right now the multitasking agent side, because I guess I've only really been doing the sort of single threaded. I've got this prompt I've got this task I'm working on, I'm going to prompt it. I've been trying to work for the last sort of 6 months, 10 months, whatever, on prompt first engineering, just more to make sure that I guess I'm keeping up with my CV and just knowing how to do it. So usually it's like, right, what am I working on? What do I need to do? I'm going to try and do this without writing a line of code myself. Can I do it with prompting?
Yeah.
And what you were saying about Spec is like trying to do the write the plan before any code is committed, code starts being generated. Would be I've definitely found that I can work quite efficiently sort of shepherding the LLM. So going, right, I've got a small task I'll ask it to do, prompt it out in English. Okay, it's doing it quite well. Good. Review the code. Next one. If I find I want to do something bigger, often I'll be like, okay, right, I'll test my luck here. I'll try and ask for more than I usually do. Rather than just say a half an hour, something that might take me half an hour. Let's do something that might take me a few hours. Let's give it a go. But often what I'll be doing, I've found, is almost not giving enough information. So I'll ask for a big ask, but I'm just doing it in a couple of sentences, but actually missing out quite a bit of potentially technical details or product definition details. So then what happens is the agent or cursor, whatever it is, will, I guess, for lack of a better term, start filling in the requirements, making up the requirements, which may be correct, maybe what I wanted, but they may also just be something that I don't want. And so I found actually I'll be quite good at going, actually, escape, stop. I can see it's going off track. I need to now fill in more information. And then what ends up happening is that first sort of couple of sentences, I've now ended up turning into a few paragraphs in order to go, actually, this is how much information I needed to give it to do that 3 hours worth of work as opposed to the half an hour worth of work.
That's really interesting.
But then actually what I found is I've used as much time as I would have done if I just did it in sort of smaller chunks anyway.
Yes.
So
that's really interesting.
So that's where I was sort of talking to you about, actually, I don't find I'm speeding up. It's like, I can get the thing to do more, but I've had to do more to start with to get it to do more successfully.
Yeah, that's really interesting. So I guess there's the question of like, what are the tricks to actually go 10 times faster with coding agents instead of like maybe 2 times faster?
Yeah.
And it sounds like what you've tried doing little chunks, and a lot of people I know do little chunks.
Yeah, it's quite successfully as well.
Yeah.
And sometimes it's like, oh wow, I did this thing that would have taken me days, and I did it in half an hour. Occasionally, you might happen to write kind of code that can work that way.
Yeah, but or you're saying like, if I want it to do something that's longer duration, then I need to give it more detail. And so it sounds to me like you're handwriting a spec when you're doing that.
Quite possibly.
You're actually ending up like going into thinking hard about your knowledge of the code base and what you need it to do and giving it quite detailed instructions. So I think there's potentially a couple of tricks that could help speed up. The first one is when you've got and you asked me actually, what about spec-driven development for existing code bases, which is a really interesting question, because like everyone's got existing code bases. Very little code is written in a vacuum. Lots of our demos are like, let's make a Tetris clone with a twist or something from scratch, but that's not actually practical or realistic in the real world. But yeah, so everything is on existing code bases. When you're manually writing out several paragraphs of detail, I think a faster way to get to that spec, which I'm going to call a spec, is instead to use a much smaller prompt, but have the planning phase where the agent doesn't write a line of code, but what it does do is it goes and it looks at the existing code base, and by looking at the existing code base, the agent then does the job of writing the more detailed 3 paragraphs, or even more. And then you just need to read it, and you're faster at reading than you are at writing. And then you just need to comment on the bits that got wrong. And so that kind of doing the thinking up front, but after the agent has generated the plan, rather than you having to generate the entire plan. So that might be an interesting thing. The other thing that I've found in my own practice is that going from trying to speed up by parallelizing, right, and actually running multiple agents in parallel. And what I found is that when you start using short prompts to generate, like it's prompt plus code base equals spec is the first part.
Yeah.
And you can use short prompts to generate longish specs.
Yeah,
and
I guess in
and
my
then check them. And
I guess in
do
my
the thinking work.
Yeah, my story earlier is I would often, when trying to do bigger things, would try to start with a small sentence or two.
Yeah.
And then find that wasn't enough.
Well, then what you said was you end up having to babysit the agent and watch it go off the rails and press escape. So compress that babysitting task into doing the thinking up front by getting it to write a detailed spec, but the agent writes the spec and then you correct it.
Yeah.
But then what I find is that when you have got detailed specs, you can, the job of actually taking the spec and turning it into a PR is at that point fairly mechanical. You still need to review the PR as a human at the end, but if the spec is good enough, the agent's just going to go and do the work. It can also run the tests. It can also interact with the CI system. It can also make sure everything's green. It can also use a browser to test things itself, right? So a lot of that work of actually doing the development work becomes quite mechanical. And if you've got a good enough spec, then you can have those running in parallel. The other fun thing, so what you can do the spec generation work across, like, you've got a backlog of 100 bugs and features you want. You can do that spec work, boom, 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 quite fast. And then you kick them off, and there's almost like a pipeline now of these agents that are running, doing the work, and then proving to you that it works. They can even like share a screenshot of their desktop with you on Teams or Slack and be like, look, it works. And then you can go and QA it in its environment, or if it's stuck, it can put its hand up and say, help, I'm stuck, and ping you a message. Anyway, so that's kind of like my best guess of like the path to actual 10x gains.
Then the bottleneck maybe becomes the human review. But at that point, I was talking to another developer about the sort of the vibe coding thing, because like I haven't done any real proper vibe coding yet. I'm still at the stage where I'm, reviewing all the code that LLM is generating. But I feel like it might become statistical in nature, if everything it starts doing is pretty good, at some point you might just be okay with going, you know what, the last 5 things it's done was actually just fine. Maybe this 6th one I won't check, and then maybe do less and less glancing. You maybe get an idea for what the important things are to look at. This bit's critical, so let's really look at this. This bit's just some front end forms, and we don't need to really scrutinize that. And I've tried various points on that spectrum of like just fully trusting it and only caring about the outcome. All the way back up to like a detailed code review. And I think you're right. It depends a little bit on kind of how hard the job is. But also these models are getting better really quickly. And so I think like we do need to do more review now. But if the spec's good enough in the future, we won't need to do so much. But then it still does lead to these problems of like duplication across the code base. And so there's almost an idea of a review agent that actually takes time to check for duplication, check that the documentation's been updated, check the other 10 bullet points that you have in your guidelines for like, this is how we code in this company or in this team or for this project. So that's I think there's scope to, I guess my vision is like bunch the thinking up front, and we end up just spending, as software engineers, we just spend most of our time now doing design reviews on easy to read, clear documents that we can comment on and get the agent to respond to quickly. So bunching up front, because I don't know, like, I find actually even when I'm just working or pre LLMs and all that kind of stuff, when I'd be working on a feature, often I feel like I could think about the thing I'm going to be doing within half an hour and then go, that's going to take me a day to do. But actually, I've kind of thought probably 90% of the way there in my head, but I've just, got to do it. It's like, I can, imagine like a sort of a bricklayer going, right, I've got this pile of bricks and this cement and I know how to build the wall. I now just need to build it, it takes some time to do it. But, they can visualize, they've done the measurements, go, right, I've got the plan. So if you can get the machines to build me the wall.
Exactly. Yeah. Cool. No, good stuff. Shall we do some spec coding together?
Yes,
definitely. Yeah, cool. So we've got 2 laptops in front of us and we can jump between them in terms of what we present here. So why don't we start with looking at what you're doing for a minute?
Okay.
And then you can probably carry on working on that and I'll do some demos.
Okay.
And by working on it, I probably mean watching.
Yes, watching it.
But yeah. So we can kind of jump around. Is that okay?
Yeah, definitely.
Yeah, cool. So I will just turn on Jez's screen share like that. Do you want to talk us through this idea?
Yeah, so I thought I would start. So this is the very start of a project in Helix. And like I was describing earlier, so this is the initial description of a very small application that I want to build. And like I was describing earlier, I've kind of gone with the idea that I need to give it quite a bit of detail because it's a big task. And so what I've learned from trying to do big tasks previously is I need to give it more detail rather than necessarily a couple of lines. Maybe I could have started with a couple of lines to really test this out, but I've kind of gone with this is probably what I'd be doing now if I was sort of back at my day job.
Yeah.
Although saying that, this is a new application, so I'm sure there should be like I've put a few technology descriptions in here. I'm sure I'd need to at least put a bit of technology descriptions.
Yeah.
Because otherwise it could do it in anything, I guess. So
get it in Haskell.
Yes, exactly. Or just like do it in like some sort of like Microsoft Excel sort of app or something like that. So I won't read it out. I could read it out.
No, it's fine. Just summarize it.
Yeah. So an application. So the idea is it would be a small application as part of a potentially much bigger application. But a key thing would be we're going to be a multi-tenanted SaaS application, and we have our clients, or in this case, organizations that we'd work with, and we'd have users. So it's not just like it's like B2B rather than B2C. So an organization is another business we're working with. They would have many users, and we need an application that we can just set up these organizations, set up the users within there, and then from there there would be all sorts of other functionality built on top of it, but like this would be the start of any kind of B2B type of application.
And then the idea was to turn it into an org chart generator.
Oh, yes. Right? Yeah. So to start with, I mean, like that's probably what I would be doing next in the kind of financial application I'd be doing. I'd need to have some sort of org chart aspect of an upcoming application I'm about to work on. But even fundamentally, before you're even doing the org chart, you've just got here are just users in general.
Yeah.
So a multi-tenanted system is we work with lots of businesses all around the place. Within that business, there are a bunch of users. Within that business, then there's an org chart around where maybe people are sitting in their like physical locations, their teams, which then depending on like the financial aspects we're doing, they might have different regulations they need to sort of be sort of adhering to, that kind of stuff.
Yeah, that's cool.
But I thought rather than trying to type all about org charts to start with, I'd start at just get some users in there.
Cool, let's kick it off.
And so great task, I guess.
Yeah. And then you can click start planning.
And
nice.
And so it here has like a sort of a GitHub repo with no files in it. It can see, is that so?
Yeah, that's right. And so you can connect. I mean, I can show you here. So we've got a couple of projects. We started one earlier. This is the new one. And each one of them has got its own Git repo. And you can also connect existing Git repos that you have in your normal tools, of course. And yeah, so basically inside here, it starts out with nothing apart from, we also have a specs branch. And the specs branch also has a startup script in it, but mostly the specs branch is for the specs. That's maybe an interesting question, actually, which is why have a separate branch for your specs versus putting them as like design documents in your main repo. And the interesting thing about that is that I like using the specs both as a design document, but also, especially when I'm working on really hard things, like a log, like almost like a lab notebook of these are the things that we tried. These are our current hypotheses about this really difficult bug, that kind of thing. And when you're doing something hard, you often need to switch around between different branches or roll back a branch if you need to do if you want to undo an approach that didn't work out. And so this process of engineering is often very sort of nonlinear, whereas the lab notebook should be linear. You shouldn't like revert your state of your lab notebook about the hypotheses and the things you're testing in the process of switching around between branches. So I'm quite of the opinion that your specs should live on a separate branch, and that branch should be forwards only, if that makes sense. So that's why the specs end up in a separate branch. But anyway, let's go back in here and take a look. So do you want to drive? You can maybe click in on that thing.
Yeah. So I've never used this application before, just FYI.
Yeah. So I can kind of explain what we're seeing here. Oh, and let me do this so that everyone can see more clearly.
Right, yeah,
it's fine. So so what you can see here is we've got basically a chat widget, which is the conversation between you and the agent. And then you've also got, and this is pretty unique to Helix, you've also got a desktop environment. And that desktop environment is the agent's computer. So the idea is, for all the reasons I talked about earlier of my pain that I've had, like trying to run multiple agents in parallel, and like how you can get to this 10x efficiency gain by doing your design work in batching that all up front, and then letting many agents in parallel kind of do the mechanical work of implementing the designs. You can't do that on a single computer. You need to give each agent its own development environment. And therefore, each agent will be able to spin up the application itself. This is going to be a web application, presumably. And you'll be able to define a startup script to boot up the stack. But anyway, I'm kind of getting ahead of myself. Why don't you take a look at the spec it's generated, and you can just click the blue review spec button.
Okay, so before I do that, I was just interested. Is that your?
So this is our prompt, basically.
Yeah.
So we say this is the planning phase.
So you're
telling it the format
being transparent.
Yeah,
about
exactly.
your prompt. Yeah, and then is this must be the spec here that has come from?
No, this is just a summary of the spec.
Okay, so
if you click on the spec,
yeah.
So what we've done here is we've got a sort of Google Docs style interface for reading the spec. And this is something I find using something like Claude Code, which I'm a heavy Claude Code user still, although I also now use Helix to develop Helix. I hate reviewing design docs in Claude Code in the terminal because it's a horrible place to read the doc. And it often just shows you the first 10 lines of it. And if you're lucky, it'll say press Control G to open in Vim. But like what I really want when I'm reading a document is to read it like a nice document and to be able to comment on it. So why don't you just kind of think out loud as you look through this quickly?
Yeah, I won't go super detailed.
Yeah,
obviously.
just pick a couple of things you want to change, basically. What's TRPC?
TRPC is a TypeScript library that produces like a type safe layer for you to call the back end with.
Nice.
But it's sort of in sync with your back end code.
Mm-hmm.
So there's no API spec. It's not like you've got some sort of open API spec in the middle.
Yeah.
Just you write a function using the TRPC backend, and then your front end just knows about it.
Oh, nice. Yeah, this is what you were telling me about at the party.
That it allows you to kind of just move very, very quickly, because you just write a function and just call it from your front end.
And it's kind of like the back end is the front end. They're both written in Node.
Exactly, okay. Yeah. But then the idea is they're very in sync.
Or they're both written in TypeScript. Sorry.
Yeah. They're very in sync. You wouldn't want to do it if you wanted to make an API for others to consume. But a lot of the times, especially in small little isolated projects, a lot of the times you're making like a back end just for your front end.
Yeah.
At that point, why bother with like the abstraction of a sort of a API spec? Just the functions are the APIs.
Okay, nice. Yeah.
You know.
So it's kind of got what you meant.
Mm.
Yeah.
Yeah. I mean, so far it's all looking pretty good. I'd hope that. I mean, I didn't ask it to do anything too complicated. So, organizations have a name. Only CPUs can create and edit organizations. I think that kind of makes sense as well. There's two.
Oh, we need to render the tables nicer.
I mean, so far I haven't noticed anything that I mean, I can suggest some changes. Just let's suggest some changes.
Also, look at the technical design and the implementation plan as well. So, so what we do here, and we were inspired by the design that Kiro have, which is the AWS project for spec-driven development, to basically break the spec down into requirements, which are kind of like user stories, technical design, which is like the architecture. The implementation plan is just a to-do list. And that's, to begin with, I was a bit skeptical. Do we really need all three? But actually, when I really use this thing, I'm like, yeah, this is actually a pretty good fit. So the Kiro team did a nice job. So should we? Yes. Okay. Cool.
Okay. This is looking pretty fine for.
We should have used a less good model. Let's do something about the implementation plan. What I might suggest as a comment, just because I want to add a comment, is that when it comes to front end, I would say something like.
I could be a bit more specific about the front end UI library to use. It hasn't specified a library choice there.
Yeah, sure, go for it.
So would I do that in the implementation plan or the technical design? Where
it will update all three. It will know as needed.
Okay, so
if you just highlight some text.
Okay. And then say, please, I'll be polite, please. Use shadcn.
Oh, nice. Yeah. We just did shadcn for our new
surely everyone's using
shadcn for our new marketing site, actually.
Although what's going to happen is it's lovely to work with, but what's going to happen is everything is going to look exactly the same. But
yeah, well,
maybe that was a same thing that everyone was doing with Bootstrap 10 years ago or whatever. So yes, okay.
So what you'll find now is when you leave a comment, the agent is immediately going to respond to the comment, and it's immediately going to update the design doc or the spec with an update to the doc. And I've actually found this is honestly a really nice way to iterate on these documents. So you can see, if you want to follow along, it's literally going to go and update the to-do list. It's already updated the design, and then it pushes the updated spec to Git, and then
nice. Even putting specific components it's going to use in there.
Oh, nice. Yeah, cool. Was that in the implementation plan?
Yeah.
Yeah. Oh, nice. Okay, cool. And the other thing I want to add is that kind of make sure you check that the front end works by loading it in the browser using Chrome MCP, because we have Chrome MCP in the sandbox, and that is honestly, I think one of the most powerful things is when you can point. I don't know if you use that much.
Not yet.
No, I started using it the other day, and I was just like, why didn't I do this sooner?
Okay.
But when you can point the agent at the web browser, you don't have to copy and paste the error messages out of the console to the agent anymore. It will just do it itself. And the more we can close these loops, and there we go. It's added that.
Do you think I should put things about linting and stuff like that, or like?
No, this is big enough already. do you want to do the honors and approve design?
Right, let's do it. Let's do it.
Only got 24 minutes left.
More comments?
No, just approve it. So yeah, what you'll see now is that we've added so kind of the whole idea here is that we're able to orchestrate many of these agents in parallel. And so obviously this is a bit of a special case because we're starting a project from scratch. But when you've got an existing project, you've got a big backlog, and yeah, like I said, it's super powerful to be able to batch up these specs at the beginning. You can spend your whole day reviewing specs and probably leave the agents to like carry on even after you've gone home, like working on the actual implementations. So while that is busy writing the code, because we don't need to write code anymore, I'll switch over to my screen. And what I'll do here, infinity mirror. I'm going to show you just a couple of things. So a couple of quick demos. So the first thing I wanted to show was I'm going to just make a brand new project, make this a bit bigger, and I'm going to call it Pac-Man v2, and I'm going to use Opus 4.5. That'll be plenty. And what I'm going to do here is I'm going to say write a Pac-Man clone that runs in the browser, but give it a twist, a surprise feature. And then I can hit start planning. And so that's going to spin up another one of these desktop environments.
Did you just use voice recording for that?
Yes.
Okay.
I use WhisperFlow, and it's really, really nice.
Yes, you mentioned that to me.
You don't even need to type anymore.
Have you got that binded to it?
Yeah, that's the function key on the keyboard here. Yeah. It's really, really powerful. So yeah, while this thing's running, I'm also going to show you what it's like to work on oh, actually, let's see. It might be quick enough to do the spec. So I'll just take a look at this. A lights out mode.
That's the surprise it's decided upon.
Yes. The maze is dark except for a small radius around Pac-Man, turning the classic arcade game into a tense atmospheric experience. Sounds good to me. So again, here we can do a little bit of design review on this one. How's yours doing, by the way? It's busy writing Docker compose files and env files.
Yeah,
it's actually put together quite a lot of stack already. Cool.
I'm interested to see if it's going to actually sort of get it all running and start the install the right node packages, get it actually doing its thing. But so far so good.
Yeah, cool. So I've gone for my my Pac-Man game. I'm going to come out here and look at the spec for that. And yeah, sounds good. Playable in the browser. I'm interested in the technical design. Okay, so it's doing it purely in JavaScript. So we don't even need a backend. Nice. Implementation plan. I'm going to say I want 2 twists. I would like an additional twist, which is that on special days of the year, Pac-Man becomes decorated in a different way. So I'm going to let the AI decide what special days of the year are. And while it works on that, I want to show that I can do something else in parallel. And imagine how difficult it would be to be doing all of these things on the same computer. But what I'm going to do is I'm going to take an existing app, right? So this one is a simple to-do list app, and I should really start using more exciting examples. But here I have a to-do list application. And if I just full screen this one, this is what we call the human desktop, because all it does is it boots up the app, and so you can see kind of what it's like. And I'm going to say I need to mow the grass, I need to feed the children, and you can see, okay, well, I can refresh the page, it remembers. I can delete one of them, but then when I refresh the page, oh, that's interesting, there's a bug. Like, it hasn't actually persisted the deletion. So I might come back out here and say, like, okay, I found a bug. And actually, if you look here, someone's already reported that bug, fixed the bug where deleting a to-do item doesn't remove it from the database. So the interesting thing here is that the bug report is actually wrong, because there isn't a database in this app. So let's see what happens when we get that thing to start planning. So that's...
I'm starting to add a database for you.
Well, it will need to make a decision, and you might want the human to like check the decision. So here you can see this is the startup script in action. So when I'll actually just show you the startup script quickly while it's working on that. But you can go in here, and the startup script is just a shell script that runs at the start of every single instantiation or invocation of an agent doing a different task on this project. And the project has one or more repositories attached to it as well. So we support like multi-repo projects, and they all just get mounted. But you have one project that's primary. But anyway, this is useful because you can then like actually like open the browser on localhost, or you can boot up a Docker Compose stack, or whatever your technology choices are, and then every agent will get a consistent development environment. And actually, that's like, I just want to switch the screen over to yours for a second, because it's kind of exciting to watch that thing like working. It's blasting through this to-do list, and it's just checked off like a whole bunch of the items on the list. I just think it's kind of exciting to see it like doing that on its own. Anyway, so back over to my screen. So if we look in here, we can look at the spec for the to-do not persisting. It's got that all right. It's found the solution. It's debating whether to refactor some shared persistence helper. It has figured out that it's using local storage and not a backend database, so that's good. So this is where like all of that manual typing that you were doing of like paragraphs and paragraphs of spec, it's kind of done that for you as well by taking a small prompt plus the code base equals the spec, and then you can just check and iterate on it. again, just because I love Chrome MCP so much, I'm going to say, don't forget, you can test this yourself with Chrome MCP. And then that's going to go ahead and get the agent to do that change. You can actually see it running here. Yeah, it's busy updates. So it's updated the spec already. Yeah, and it's saying verify with Chrome MCP. So I'm going to say that comment's dealt with. Happy days, approve the design. And then this one should hopefully be kind of nice and quick. So it'll switch to the feature branch, creates the feature branch. And then we've got this one running next to the actual app in the browser. It's gone and fixed the bug. It's found the bug. It's fixed it. And honestly, I actually think watching your screen's more exciting here because it's busy furiously writing code, whereas my example is trivial and silly. But yeah, so the thing I really want to just show here is that it's now going to actually test. It's going to do the job of testing the implementation is working on its own. Let's see if it succeeds with that. So it's now going to use the MCP to open a new browser. It's taking a snapshot of the page. It's adding a test to do for deletion. This just feels like magic, honestly, like just watching it run its own QA. It's refreshed the page and confirmed that the bug is fixed. So that's cool. The deleted to-do did not appear after the refresh. The fix works. It's now going to do a more thorough test case with multiple to-dos. So it's going to say it's going to delete the second one and do a third one. And it's going to delete the middle one. So it's doing a slightly more interesting kind of experiment. And it's refreshed the page and it's happy. So that's great. It's going to wrap up. We can then accept the task. And if this was connected to a GitHub repo, it would then open a pull request. And then you can go and approve the PR. And so while it just finishes up there, let's go and look at the other project. Because remember, we've kicked something else off in parallel. That was Pac-Man v2. So I'm interested. Oh yeah, we never actually kicked it off. So let's approve that. And then it's actually going to go ahead and implement Pac-Man. So while it does that, let's come back to your screen and dig into what that one's doing. So it might be interesting if we leave the agent, unfull screen it, and let's look at kind of the view here. So here, this is, I quite like this view of like, imagine you've got many of these running in parallel. You can see it's kind of 33 out of 55. So, and you can kind of get this live view of what it's working on. So it's really nice to have this kind of like, this is the rundown of my progress. And I'm kind of this far through it. But then if we go back in, we can see it's just furiously writing React code. It's like, honestly, it's so fast. Yeah, it's just going.
So it's done the back end already, and it's done the Prisma database stuff.
Yeah,
I imagine it's getting close to being done.
Yeah. So if you unfollow the agent, then you can maybe kind of poke around a bit. I don't know if you want to actually explore the code it's made and
So let's
decide what you think of it.
Okay, yeah, guess I don't need. Okay, so this is different packages, isn't it? So this has then got the front end packages. All making sense. I've not used Prisma before, so I probably don't fully understand.
Oh, interesting. It's another language. It's
JSON-like kind of language.
It's intriguing.
I'm always a bit dubious when things decide to make their own schemas, but
yeah.
I guess if this was just JSON, it would be harder to read.
Yeah. Yeah, it's a special language just for specs or for schemas. Yeah. Cool. I mean, while that's working, if you've got any other questions or discussion topics you want to cover.
I'm sure there are probably hundreds when I start, if I really get down to it.
Yeah.
Probably more along the lines of the review and testing stage, maybe in what you've been working on so far with Helix, in that probably to go from, say, a 10 times to 100 times kind of speed, at some point we're going to need to not human review code to a certain degree. And I wonder, what's your feelings on how much testing in general should be done? It's in terms of, do you sort of get Helix to write lots of unit test suites, integration test suites? And then, because I feel like in our company, we probably do not enough testing. We rely on our QA department more than we rely on developers doing extensive tests. But I think sometimes it comes down to a case of your tests, your coverage is only good as your tests.
Yeah.
So if you write a load of mediocre tests, then you're not actually testing your core application. And actually writing good tests can be as hard as writing a good application to actually cover all of your use cases. And what we found, especially when we're working on new projects or fast-moving projects, sometimes tests can actually get in the way to a certain degree. So be combined with probably a fact that developers are usually more expensive than QA. It's like, do we get a developer to spend more time writing unit tests when we could just sort of push that, saying a bad thing, but be more efficient?
Oh, look, you've got a sign-in screen.
I do.
Yeah, but yeah, no, it's an interesting question about the test. Oh, and look, I've got Pac-Man.
Yeah.
7 minutes before the end.
Yeah.
But no, do you want to just, do you want to like take a look at the app? Or I mean, it's testing it as you go. So let me just, and I'll think about your question.
So this is, it is using this Chrome. Yes. So I shouldn't.
You shouldn't interfere.
No.
Bloody hell, look at that.
Yeah.
It's quite good.
Yeah.
So it's quite nice to kind of put them side by side like this. I think it's an interesting question. And I've got Pac-Man up here now, so I'm getting distracted. I'll show you my Pac-Man just really quickly. Oops. That one there. So I've got Pac-Man lights out mode.
It's playing Pac-Man.
Yeah. I need to play Pac-Man. Sorry, I need to not die. But I think the interesting thing about testing is, it's sort of this perennial. Oh, that's a bit of a bug. Slightly off by one. Anyway, there's this sort of perennial question of testing, which isn't specific to agents, but of like how much, how much do you unit test versus integration test? The problem with like real end-to-end tests is that they're so flaky. Like every time I've tried to build like a proper like browser-based testing suite that actually tests what you care about, which is the end user-facing value of your product most of the time, if you're building web applications, then if you go full end-to-end, then they're just so freaking flaky.
And slow.
But if you overdo it on the unit testing, then you find if you want to change something substantially, then you end up having to change the unit tests just as much as you change the implementation. And so for me, I think a large part of this is like, what is the code for? Is the code currently being used for testing a new idea in the market? In which case you care more about time to market than you do about maintainability. Or have you got some traction with an idea in the market, and now you need to demonstrate, and now you need to actually make it work for real in production at scale? And so a large part of the testing question comes down to what phase are you at? But I think that AI also, I mean, we can see it right now on your screen. AI is now able to do QA. So like there's probably some sort of argument for using like AI-driven browser testing to do a less flaky version of the Selenium tests of your, but yeah, I don't really have an answer though.
No, I guess it comes down to if you can speed up development using LLMs, you can also speed up test generations using LLMs.
Yeah.
But it's still more work than it would have been without the tests being there.
Yes, like until you needed them.
Yeah.
Yeah.
And then when you make a change, if there's loads and loads of test coverage, that also has to change, then the agent will take longer to do it.
Yeah,
it has to go and change a load of other stuff.
And I think what it comes down to for me is basically tests are good. But you should have the right amount of them at the right level.
Yeah.
And so having like one or two end-to-end tests that test the thing that really matters for your application is critical. And then unit tests on anything that's hard.
And I guess at that point, whether it was LLM like old school developers writing the right levels of tests in the right places versus LLMs writing the right level of tests in the right places. I guess I was thinking maybe like, oh, we've got LLMs, we can do this stuff really fast. Let's just cover it in tests to really make sure that the thing is solid. But maybe that will just slow things down just as it would as if a human was doing it.
No, that's interesting. Cool. So there was one last thing. We're coming up to the top of the hour. There's one last thing I wanted to reveal on this live stream, which is that we now have a working Mac app. And so it is possible to boot and run Helix entirely on your Mac with an app that you can download. And we've done some really fun and interesting and difficult kernel hacking in order to make multiple agents, each with their own desktop, on virtual GPU outputs on a Linux virtual machine running on Mac OS work really well. And there's a post about that on our blog. So anyway, we are opening up the beta in the next few days. To anyone who's watching, who's been waiting for the beta, thank you for your patience. I know it's taken a bit longer than we'd hoped, but we are opening things up kind of in the next few days. And also, if you're interested in trying out the Mac app, then yeah, please join our Discord. The invite is here, discord.com/invite, followed by that. And I'm just going to put that in a massive text. So anyone watching the stream can see it. So, there we go. So yeah, thanks everyone for coming or watching later. Feel free to join our community. And Jez, thank you so much for coming and spending some time with me this evening and chatting about spec.
You're welcome.
Coding.
Thanks for having me.
Yeah.
I'm sure I'll be asking you lots more questions as time goes on.
Awesome. Yeah, thanks very much.
Thank you.
Cheers. Thanks everyone. Bye.